Hey everyone, I'm back to solve Advent of Code 2025 Day 2. So today I'm slightly different setup, I'm in my room, so uh, yeah, still trying to figure out the screen resolution stuff. But let's see today's problem. So it's the gift shop. So the product IDs are the inputs, so let me just paste that in. So again, I have a custom format file structure that I've written for this. Ranges are separated by commas. Each range gives the first ID and last ID. Since the young elf is doing silly patterns, invalid, only made of a sequence of repeated twice. So 5 repeated twice, 64 repeated twice, 1, 2, 3 repeated twice will all be invalid. I see. Okay. So find all invalid numbers that appear within the range. Okay, so let's just parse this first. So I think it's a single line. So let's just say that the line is the contents strip split by comma for every range. Let's call this range raw in the line. The range raw can split by the hyphen character. We can say this is the start and the end. Oops. Let's go back. And we can call this ranges. We can say we range append the start and the end. Let's just return the ranges. Cool. So we should be expecting a list of tuples where both are integers. So let me just print to make sure that we are parsing the data correctly. Let me increase the font size just a little bit. Again, I have a CLI that handles a lot of the for brute work that I'm doing. So let me just test it. Okay, cool. I should parse these as numbers. So int and int. Okay, cool. So because they said that none of these would start with a leading 0, even if they do, we can ignore these. Okay. So the next thing we want to do is we need to then perform a check to see if a sequence of digits is repeated. So the way I can think of would be to check is well, it's called is valid, right? And then let's just declare a helper function for this. Return false on this for now. Oops, return false on this. And let's see. So okay, I don't really need the input anymore, so let me just close it. So essentially what we want to do is a sort of brute force approach would be for every, let's say, start and end in the data provided, for I in range of start till the end, we just check answer is 0, and we check if answer can increment by the int form of if it is valid of I. Cool. And then so this would be the general function if you are brute forcing it. So now we want to try to figure out how do we actually solve it. So one way we could do it is we can calculate all substrings that make up the given number, and then for each substring store its frequency, and then if the frequency made up only of some sequence of digits which is repeated twice, so if frequency is greater than is equals to 2, then return false. So that is one of the ways we can do it, right? I think that is possibly one. So it would look something like the SN is the string version of the number. For I in the range of the length of SN, for J in the range of, so we want all of the substrings, so everything up until I. Let's see, the frequency the frequency, well, the substring is equals to the Sn from from j till I. Yeah. And then the frequency of S is the frequency of S plus 1. Made up only of a sequence of digits repeated twice. I'm trying to think. I think there's also some alternative pattern where if we duplicate the number twice and the number exists within itself, then we know that it's a repeat. 4, 4, 6. Well, I think this is not the case. I think I've seen a pattern before where if we do this and we say we remove this, 4, 4, 6, and then 4, 4, 6. Yeah, so I guess there's a potential pattern where if you find the number within itself again, then it would be the answer. So potentially what we could do is we could maybe do say Sn is the string of the number, return Sn plus Sn from 1 till -2, and then we are interested in checking if Sn is in. So this might be the answer. I'm not entirely sure yet. Doesn't seem like it, so I think that's okay as well. But maybe let's just do if not self is valid. Let's just print out I. Yeah, so you can kind of see here that it is not really getting it right. So yeah, so actually this is quite silly, but if it's repeated twice, you must, okay, scratch that. So if it's repeated twice, you basically split the string in half. So if the length of the Sn modulo 2 is 0, let's just say it is not 0, true. And then if the Sn for everything up until the length of Sn over 2 is not equals to everything of Sn over 2 till the end. Yeah, so we can kind of see here now it actually produces the right values. Cool. So if it is not, yeah, seems like it's correct now. Yeah, so I think I was caught up in trying to optimize it a little bit too much. Basically, the idea is a valid string just has to appear twice. Cool. So let's just do day 2 text, and let's get my puzzle input for this. And let me just run the CLI without the test. Okay, cool. Yep. That was a lot simpler than I thought. I think I overthought that. It's okay. Let's see. Now the number is only invalid if it's made of at least 2. Right? Okay, so we no longer can really make this guess that it is invalid based on cutting it in halves. So what we could do is we could actually do some chunking. So we could do something like is valid chunk, and we can call this the chunk size, which is an int. And essentially we can generalize this behavior where if it is not if you cannot modulo by the chunk size, we can return true, and we can say that the chunks are basically equivalent to, for I in the range of the 0th to the length of Sn for every chunk size that is given, and we are interested in the value starting at I, ending at I plus the chunk size. Return all of the, so if for each chunk in the chunks, if the chunk is equals to chunks of 0, right? So we can kind of copy this over, and instead of doing this, we could say, let's just say is valid 2. The naming can be better. Let's just solve this first. So we say boolean, and we simply get the Sn first, and what we want is we want to vary the chunk size. So we say chunk size in the range of 1 till length of Sn, and the minimum number is 2, so we can just divide this number by 2. So yeah, so we can then return if is valid on the chunk size given this same number but with this given chunk size. What we want to do is to return true. Return false. Otherwise we return true. I guess it's not really this, so we can maybe rename this to is repeated, right? And then we would solve this by using is valid 2. Let's just test this again, and we can kind of see that it's wrong, so maybe let's just print out the I to just check what's wrong with this. Let's see. Okay, so it picks up 11, it picks up 99, it picks up 1. That's also valid. It picks up 10 and 10, that's also correct. It picked up a invalid number, which is this. So I do wonder why it did that. So maybe let me just triple confirm the chunks. I suspect we just didn't add a 1. Let's see. We were checking for 1, 1 and 2, 1 and 3. Okay, so this is fine. Okay. So for some reason we were not able to pick out the right chunk size. So this string is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should have gone from yeah, so it registered this as being correct, which I don't think is actually correct. So let's see. Okay, let's just print out the chunk size just to make sure it's correct. Yeah, so for some reason it is falsely taking this, which doesn't really make sense. So we take 11, 88, 51. If the current chunk for every chunk in the chunks is equivalent to the very first number. Okay. This is a bit odd, but let me just confirm why it is failing in this way. Yeah, so against it all, it is picking 11. So how come this is printing true? I'm not too sure either. Oh, it is false. Okay, okay, cool. So it is returning as false. But I'm not entirely sure why it is triggering the skip on this. I might have made a logic error on this. Let me just double confirm it. Okay. With the 1100s. Ah, okay. Okay. So it is successfully picking up 6 as the maximum chunk size. So how come it isn't working till number 6? Okay, let's just do chunk size to try. This is pretty odd. Yeah, so it tried chunk size of 2. It tried chunk size of 3. But then it failed. Hidden chunk. Let's just see. This is slightly annoying because I think the logic should matter. Yeah, so we said that the chunk size of 3. Okay. It's because we said that the length of this is that, so it should be is false. Yeah, there was a slight logic error here. Okay, cool. We finally caught it and we fixed the issue. So let me just remove all of the print statements because we know that this logic works now. Okay, cool. Yeah, so you can kind of see here they picked out the correct answers. And let's just see. So it's kind of running through all of the possible answers. Maybe I should not print it at all, but it's okay. And let's see. Cool. Yeah. Cool. Maybe let me just do a bit of cleanup before we proceed. Essentially, what we are doing here is we are simply saying if it is self dot is repeated, where we give it I and we say that the chunk size is 2. So we no longer really need to brute force is valid here. And I guess in very similar fashion, we can kind of discard this. So this is actually a Sn directly. And Sn equals to the string of I. And then we can bring this chunking logic over here, where we simply check the answer plus equals to I, and we can pass this as n. We don't really need this anymore. String of I. Yeah, cool. I think if we just remove both parts. Yep, so you can see here that now with the, I'm just doing a bit of cleanup, it is not very accurate because I think the very first answer was wrong. So let me just yeah, so you can kind of see here it overcounted. I think it's because Sn we go from the start of the data. Yeah, okay, so the refactoring changed things a little. Yeah, so the chunk size should have been 2. So if it is repeated, I'm just curious why this refactoring didn't work. 1112 triggered it, so how come? let me just do part 1 first. Okay. For some reason, it is still producing this. So maybe let's just check to make sure. Ah, okay, because we say that the chunk size here is divided into 2. So I guess we can't really generalize the behavior as much as we wanted it to, because the first is valid kind of looked at it and the perspective of literally splitting a string in half, whereas in this case here we are saying the chunks or the size of the strings is equivalent to that. So I think it is only valid if we actually do it, let's see, if we actually do it this way. So we can say is repeated, and then let's just bring the chunk size in the range of 1 till s of n is the string of I s of n over 2 plus 1. If it is repeated of s of n of the chunk size, so I don't need this, I'm just going to say that this is going to be a string. Let's just call this s of n. And for the second one, the logic is slightly pretty different. So the first thing we actually care about is s of n is equals to the string of I again, and if s of n modulo 2 is not equals to 0, we can continue. Otherwise, what we do is if is repeated, where we give it s of n, and we literally give it the length of s of n over 2, then we can do it. So in this way, we can actually generalize the function. I think this should be correct now. Let's see. S of n modulo 2. So let's see, we can do length of the s of n modulo 2. Yeah, so I think it is more true to the actual solution that we had. But oh no, why did it fail? Oh, that was a typo. I think this should be good. No, it's not. Why is it failing? Let's see if it is repeated for this given chunk size. Ooh, why is it not working with the optimization here? Let's see. Sn is I. The the chunk sizes go from 1 till half of the length of s of n, and then what's up with this solution here? Why is it okay? Now I'm kind of curious what's causing this to fail, because it was working just now. Okay, does it work for the test? It is not working for the test. Okay, so 1 and 1, 1, 9, 10, 10. Okay. Okay, it gets double counted. Yeah, it double counted a couple of these numbers. Because in the previous solution, when it double counted, it succeeded, so it returned. But because we are in a loop, we actually have to continue. Oh, sorry, we have to break from this chunking loop. Okay, yeah. That was like a silly mistake on my end. So once we find the appropriate chunk size, which is the first instance, we can sort of terminate immediately. So I think we were just overcounting the number of times. Okay, cool. So maybe let me just do a quick recap. essentially for this problem, for for the first part, we assume that if it's only made up of two duplicates, we strictly split it into two parts. And because we strictly split it into two different parts, we can assume that if the length is not divisible by 2, it is not a possible answer. And we have this function that just checks if a chunk or if a string has been comprised of duplicates, and we check this by kind of chunking them. If we realize that none of these chunks are duplicates of each other, means that it is not repeated. Otherwise, we would have it. I guess one other thing that we kind of missed here is that it says that some sequences is repeated at least twice, so we could actually change this to be 2 so that we no longer rely on just the single number. And I think that to some extent we got a bit lucky. Oh, sorry, it is repeated at least twice. Sorry, so it doesn't mean that the chunk size is. It should actually be if the length of the chunks. Well, no, because we already divided by 2, we're guaranteed that. Okay, sorry, forget about that. But yeah, so essentially we have this chunking function that just chunks up the string for some given size, and we just check if all of the chunks are equivalent to each other. For part 2, because we say that we have to be at least repeated at least twice, we can literally just try all of the possible chunk sizes. If we do find a chunk that immediately fits, we can just break, so we stop checking, so we avoid duplicate checks. But cool, let me just save this and say solve day 2, 2025. And that's about it. Thank you for watching.